Okay, so we have a question here, and it's question 2, and it reads something like this. It says that a 20 kg block is resting on a rough horizontal surface. If it's they mentioned the word rough, you should know that there's friction, and is connected to blocks P and Q by a light inextensible string moving over a frictionless pulley. So we have this 20 kg block over here, and it is connected to blocks P and Q with a combined mass of M, and through this string here, which is called said to be light, so we don't need to consider the mass of that string, and this pulley over here is said to be frictionless. And they saying that blocks P and Q are glued together and have a combined mass of M. So these two blocks are glued together, and their combined mass, like I've mentioned, is how much? M. A force of 35 newtons is now applied to the 20 kg block at an angle 40 with the horizontal. So you see this angle is acting in a diagonal direction. It's making an angle of 40 degrees with the diagonal, with the horizontal as shown below. And now the question continues to say that the block experiences a frictional force of magnitude 5 newtons. So now they've given us the magnitude of the friction as it moves to the right at a constant speed. So it's moving at a constant speed. It means that it's not accelerating, its acceleration is 0. And here are the questions. The first question says that you should define the term normal force. Draw a free body diagram of the 20 kg block. It's 5 marks. Calculate the combined mass of the two blocks. And then 2.4.1 says at a certain stage of motion, block Q breaks and falls off. So let's go up a little bit. So this block that falls off after a while. And then the question says, how will each of the following be affected when this happens? So this is a sort of an analysis question, and it says the tension in the string. Will it increase, decrease, or remain the same? You're just supposed to provide increase, decrease, or remains the same. It's 1 mark. And then the velocity of the 20 kg block, how will it be affected? Will it increase, decrease, or remain the same as well? And then you must also explain your answer. So now let us just get straight into doing the question. Start with question. That question was question 2. It was taken from last year's final exam, if I'm not mistaken. And the first question wanted us to define the term normal force. So we've already defined what a normal force is in previous lessons, and we said that it is the perpendicular force of an object exerted by a surface that is in contact with it. So again, a perpendicular force on an object exerted by a surface that is in contact with that object. And then question 2.2 wanted us to draw a free body diagram of the 20 kg block. So I'm thinking you actually have this question. So remember what the 20 kg block. So the 20 kg block was actually on that horizontal surface, and there was a force here. I think it was like this. Let me look. Yes, there was a force there, and of this thing being pulled, and it was making an angle of 40 degrees with the horizontal. And we know that there's friction, so let's draw a free body diagram of this. And the marks for that is how much? Is 5 marks. So we definitely know that the surface will exert a normal force on the object. Then we say Fn, and then we know that there will definitely also be gravity. We call that Fg. They said that the object is actually moving to the right, and we can take right as positive and then left as negative. So if it's moving to the right, it means friction is actually in this direction. So it is in the direction opposing motion. So that's Fr, and then we have what else? And remember now, there's a string. This object was connected to two masses, the two blocks P and Q, and the force in a string, we call that a tension. So we also have a little bit of tension. Let's call that Ft. And then we have that applied force. We can just draw it over here and we call it Fa. So that's how you normally draw this free body diagram in this situation. So I hope that is making sense. And remember, like I always say, you should also mention this is the normal force. So on the side there, just tell the examiners that Fn is normal force, Ft is tension, Fg is gravity, Fr is friction, and Fa is your applied force, so that they know what is it that you mean when you mention Fa, F what, and all of these things. And now the second question, let me just remove this. Now the question 2.3 is asking us, let me look. So question 2.3 is asking us to calculate the combined mass of the two blocks. So we drew a free body diagram. Let me draw it again. Also, this was the free body diagram for the 20 kg block. So before we can answer this question, let us draw the free body diagram for the P and PQ block. So because it's hanging, there will only be Ft, which is the tension, and gravity, which is Fg. And let us say right is positive, and then left is negative, and then up is negative, and then down is positive. So there we are. And to actually find that mass, we have to use Newton's second law of motion. So remember, Newton's second law of motion mentions that F net equals to ma. So the total net force is equals to the product of mass and acceleration. So we can find F net for both the 20 kg block as well as the P and Q block. So we have F net equals to ma. And then remember, okay, I don't think everything is gonna fit here. Fa is equals to mf net. And then remember, we are only interested in the horizontal motion. So we have to check how many forces do we have horizontally. So we have Fr, which is negative because we said left is negative, plus Ft, which is positive. But also remember, this angle, this force is acting at a diagonal angle, at a diagonal direction. We have to resolve it into its x and y component. So the x component will also be facing that way. So it meaning that it will also be negative. So it will be negative Fa x. So I've already showed you how to actually resolve that thing into its x and y component, and then this entire thing will be equals to ma. But remember, because it's moving at a constant speed, its acceleration will be 0. So we know the value of Fr they gave us. They said it's 5, so we just put minus 5 there. We don't know what tension, the value of the tension is, and then minus so the x component of the applied force would be F, the cos of theta, which is equals to m times 0. This is 0 here, will be 0. And now minus 5 plus Ft minus that force is the magnitude of that force is, where now I forgot, I think it's 35 cos of, makes an angle of 40 degrees if I'm not mistaken. Let me check quickly. Yes, 35, it makes an angle of 40 degrees. And now it's just a matter of a simple calculation. So if you take everything we want to be left on this side with Ft, which is our tension, we take everything to the other side, and we have 5, it becomes positive, plus 35, the cos of 40 degrees. You put this in your calculator, I think you should come to a value of about 31.81 newtons. So now we have that value. So now let us find F net for this situation. So we only have two forces. So we said that Ft, we said up was negative, so F net will be equals to ma. And then because it's moving at a constant acceleration, it's still going to be the same thing. A is going to be 0. So it's going to be negative ft and then plus fg, because we selected downward motion as positive in this case. And then 0, then the entire thing is just going to be equals to 0. We have already found what ft is. We have minus 31.81, and we know that fg can actually be written as mg, which is our weight, plus mg. It's just a matter of taking everything to the other side where we are left with, we don't know the mass, that's what we're looking for, but we know that g is 9.8, and this entire thing is equals to 31.81. And then, meaning to find m, we simply divide 31.81 by 9.8, and it's going to give you a value of 3.25 kg. So now we have found the mass for that. And then the question following that is asking us to, they say that at a certain stage of motion, that block Q will actually break. So, and now they're asking, how will each of the following be affected? The tension in the string. So let me try to, I don't need to redraw this because you have the question. So though that block, remember we had two blocks, P and Q. Connect, there's a pulley, it's connected to this, blah blah blah. It's just a rough sketch of that situation. And then after a certain time, this block will actually break off, and then we are left with only P. What will happen to the tension in the screen, in the string? I think it's pretty obvious. If the mass reduces, then the tension, the force of tension exerted in the string will also decrease. So the right answer there would be it decreases. And then the question following that is that what would happen to the velocity? So what do you think will happen to the velocity of that system? So the velocity of it will also decrease, and this is because the tension in the block, in the string, will decrease. And then this means that now, remember, the acceleration for this was 0. If we remove that block, we're going to now have a negative acceleration, and this block is actually going to start moving to the left, because now it's going to accelerate to the left. That's why this thing is going to be negative. And now, because acceleration is directly proportional to velocity, so if the acceleration decreases, the velocity will also decrease. And I think that actually brings us to the end of this question.